Hello, good morning everyone. My name is Lily. Welcome to join the Minitab web demo. Today's topic is capability analysis. First, let me introduce what is Minitab. Minitab 18 is the leading statistical software for quality improvement and statistic education worldwide. Thousands of distinguished organizations rely on Minitab 18's powerful capability and ease of use, including American Express, Pfizer, Coca-Cola, Microsoft, eBay, and IBM. The world trusts Minitab for quality. For more information on Minitab software, welcome visit our website www.minitab.com. Minitab was originally developed in 1972 at Pennsylvania State University. We built this software because we want to help professors teach the statistics using the computers, so students could focus on learning statistical concepts rather than on performing manual calculations. Minitab is an all-in-one statistical and graphical analysis software. After applying the software, it can help you reduce the waste, increase the profit, and raise the quality standard. These are the common tools in the Minitab, and I use the demand methodology to expect. D stands for define the problem. We can use the Pareto chart, control chart, capability analysis, graphics to define the problem. After this, we go to the measure. Measure stage, we can use the gauge R now. Next is analysis, or we want to determine the significant factors, or we want to do the comparison. Then we can use the hypothesis test, ANOVA, correlation, regression, and graphics. And next is the improve stage. Then we can use the ANOVA, regression, design experiments, and response optimizer. And the last is called control stage. Then we can use the control chart, capability analysis, and reliability. Minitab is designed for statistical analysis and Minitab friendly user friendliness, open presentations, flexibility, and doubt analysis available. We provide a free technical support. Let's say you face the installation problem, or you want to check the function in Minitab. Welcome, drop email to us. And we also provide a convenient training, and also provide a resource for the success, like the mentoring and the automation project. For more than 40 years, the company around the world trust the Minitab, and they come from the different industry, like automotive, semiconductor, healthcare, service industry, and so on. So let's move to topic today. Today we cover capability analysis. First, let me introduce what is a process capability. Process capability is the assessment how well the process delivers what the customer wants. So normally we use this histogram to represent our process, and this dashed line is called lower spec limit, upper spec limit. These two lines represent the customer one. So ideally, I hope this histogram is within the spec limit, and the center of the histogram is very close to the nominal, and there are no value outside of the spec limit. Then why we use capability analysis? First is the variability in a process low enough to consistently provide the part that fall within the spec limit. Does the process need to be shifted to operate more effectively within the spec limit? And is the hospital medication delivery system meeting the spec? And which vendor consistently provide the superior quality parts? So here are some examples how when we apply the capability analysis. So these are the capability assumptions. If we cannot meet one of the assumptions, our result might be wrong. So first one is called process stability. We can use the control chart to check the stability. Second is we must make sure the data follow normal distribution. So first one, stability, and we can use the control chart. If your subgroup size equal to 1, and we can use the IMR chart. If your subgroup size 2 to 8, then we use the S bar R. And if more than 9, then we use the S bar S chart. Okay, so we must make sure all the points within the control limit, there are no any points out of control limit, or show the special patterns. If the process is not stable, then we cannot use the data to predict, and we also cannot guarantee we can fulfill the customer requirement. So this is an important assumption. Second assumption, we want to check the normal distributions. We must make sure the data follow the bell curve, and we can use a few tools to check this. First and most common is called histogram. Make sure the data follow the bell curve. Second, we can use the normal probability plot. Then we look at the p-values. So this normal probability plot is used the Anderson-Darling hypothesis test. So these are the hypothesis statement. So now hypothesis, data are from a normally distributed population versus the data are not from a normally distributed population. So if the p-value, if this p-value are more than alpha 0.05, that means the data follow the normal distribution. Another option, we can use the capability expect, and this function will check the normally distributed populations. This assumption as well. Okay, so now we go to the capability statistic. So process capability statistic, they have a few values like CP, CPL, CPU, CPK, PP, and so on. So they are numeric measurements of the process capability. And since they measure how capable a process is meeting the spec. Okay. And CP, CPK, PP, and PPK statistics are measure of potential and overall capability because the process information is reduced to a single numbers. So you can use the capability statistic to compare the capability of one process to another. So many people consider 1.33 to be a minimum acceptable values for the process capability statistic. A value less than 1 indicates your process variation is wider than the spec. So these are the guidelines from the AIAG. Okay, so if the CPK more than 1.33 means your process is capable. 1 to 1.33 is marginally capable. If less than 1, then it's not capable. So now we use the diagram. So if the CPK more than 1.33, so this one is an ideal case. We can see all the histogram within the spec limit. If CPK close to 1 or 1 to 1.33, so the length of the histogram is very close to the length of the spec. So in this case, the user must control the process very tight because the mean shifted a bit, then a lot of the part will start fall outside of the spec. And this is the worst case if the CPK less than 1. And you can see the variation of the histogram is very wide. A lot of parts fall outside of the spec. And this one, the mean shifted. Okay. So the first case, we need to study how to reduce the variations. Then second case, we want to study how to shift the mean to center. Okay, now we move to the example. So this company is from the automotive, and they produce the camshaft. The spec is 600 plus minus 2 millimeter long. If they cannot make the spec, then they have a lot of problem. So in this case, they'll set the target. The requirement is 1.33, and we choose 100 samples and 20 samples of 5 camshaft each, and from all the camshaft used at the plant. Then we go to the data worksheet. Okay, so this is the Minitab project. First row, this is the menu bar. It's used to call the Minitab function. For example, we can go to File, New, to open the new project, new worksheet, or you can get the data from Excel, text file, or other software used to open. You want to save project, then use Save Project. Get the data from database, we use ODBC. And we do the analysis, use stat, graph, and assistant. Second row, this is called toolbar. Toolbar is a shortcut to call the command. And this is a session. Session folder is used to store the output. This is a worksheet. It's used to input the data. And now we look at this data worksheet. Their pattern is look like the Excel, but the concept is slightly different with Excel. Excel is cell-based, but Minitab is a column-based. So we must make sure the data stored in the column. So in this case, there are few ways to fill in the data. Or we can come to here, key in the data manually, like 1, 2, 3, 1, 2, 3, or we can fill in the date time. So you can fill in the data manually. Or you can go to the Excel, copy and paste. And third, we can go to File, Open. Then we can get the data from the third-party program. So this is how we input the data. So now we go to fill the data. See, we have 3 suppliers, or 1, 2, 3, and the C4 is a subgroup ID. So every time I choose 5 samples, so this is a subgroup number 1, and this is subgroup number 2, subgroup number 3, and so on. So every time I choose 5 samples. So now we want to run the capability analysis. So we go to Step, Quality Tools, Capability Analysis, or Capability Expert. In Minitab, there are a few ways to run the capability analysis. Besides use the step, we can try assistant. So I show the regular menu first. So we use a suspect normal. So this capability suspect, it can help us check the assumption together. So we go to Step, Quality Tools, Capability Suspect, Normal. And fill in the dialog box. Supplier 1, just double click, and subgroup size. If this one is subgroup sizes equal numbers, then you can directly fill in 5. If the subgroup size are equal numbers, then we can fill in the subgroup ID or fill in the C4. So it depends on the user. Then we fill in the spec limit. So in this case, my lower spec is 598, upper spec is 602. Let's say I don't have the upper spec, then you just leave it blank. Then Minitab will take care of everything. Don't fill in other values. Okay. After this, then we press OK. So very simple. Just go to Step, Quality Tools, Capability Suspect, Normal. Then we complete the dialog box. Okay, so now I try supplier 2. Okay. Or we can press this button. This is called edit last dialog. It can go back to the previous command, so we no need to repeat the step to call this function. So fill in supplier 3 and press OK. So we want to view the output. We can go to section or view the output. Just double click, view the output, or we can go to graph folder. So user can choose one of these. So we go to supplier 1 and we check the assumption. First we check the stability, then we use the control chart. Just now I fill in the subgroup size equal to 5. So Minitab display the S bar R chart. So very simple. We measure all the points within the control limit and no point turned to red colors. Okay. So means this one is stable over the time. And next we check the stability. Check the normality. Okay. Check the normality. So how to check the normality? First we look at the diagram. Make sure all the blue points follow the red line. Make sure all the blue points follow the red line. If this graph look like the C curve, for example, here they display the long tail, or S curve, or one point very far to the others means they are not normal. Okay, so besides use this method, we can try the p-values. So we use the p-value compare with the alpha 0.05. If this p-value more than 0.05 means the data follow the normal distribution. Okay, I show example. Okay. So this p-value is used to use this hypothesis statement. So p-value more than alpha will refuse to reject H0. So data are from a normally distributed population. Okay, after we fulfill these two assumptions, next we can look at the CPK and PPK values. CPK 0.92 and PPK 0.95, but my target is 1.33, so this one is lower than my target. And since the CPK and PPK close to 1, so the length of the histogram, is very close to the length of the spec. So in this case, the user must monitor the process very tight, because if the mix shifted a bit, then a lot of part will fall outside of the spec. Now we go to supplier 2. First we check the assumption. So there are 2 points out of control limit. So in this case, we want to study what happened of these 2 subgroups. Okay, before we move to the CPK and PPK values. Okay, so we must make sure the process stables. Then we can go to look at the CPK and PPK values. So now we go to supplier 3. Check the stability. Okay, stable. Then we look at the normality. The p-value more than alpha, so means they are normal. After this, we check the histogram. Oh, very beautiful. All within the spec limit, and we can see the spread. All the histogram is within the histogram. Within the spec limit. And now we look at the CPK and PPK values. Okay, PPK 1.54. So 1.54 is more than our target 1.33. So means supplier 3 is the best. Okay, so this one is how we run the capability step. And some users, let's say they don't want to display or they don't want to show the control chart and show the normality test. so they can try another method. This is under capability analysis, normal. Capability analysis normal. Fill in supplier 1, subgroup size 5, and fill in the lower and upper spec limit. And this boundary is the hard limit. For example, waiting time cannot be negative, so we can set a boundary. Or the water temperatures cannot more than 100 degrees Celsius. Okay, so we can set the hard limit here. Okay, if you don't have, then you just leave it. Then hit OK. So this one is another way to run the capability analysis. Then this one can display the histogram and the overall capability and potential capability information, and also show the overall performance. Okay, so in this case, observe is to check how many bar outside of the spec, so it's 0. Then this expected overall is referred to this curve. Then we check any value outside of the spec limit. Okay, so this one, the unit is a ppm, part per million. Okay, so it's 3369 per million out of the spec. Okay, so this one is another way to show the capability analysis. And sometimes some user want to do the comparison. Then we can try multiple variables. Okay, so it's under Stat Quality Tools, Capability Analysis, Multiple Variables, Normal. And then we fill in the dialog box. We choose supplier 1 and 3. Subgroup size go to 5. I choose supplier 1 and 3 only because supplier 2, their 2 point out of the control limit is not stable, not fulfill the assumption. So I use supplier 1 and 3 only. And then fill in the lower and upper spec. Then press OK. Okay, so first they will check the assumptions and make sure the p-value more than alpha 0.05. Okay, and all the points follow the central line. Then we look at this. This can use for comparison. Then why I choose supplier 3? Because the PPK hit the target above 1.33, and we look at the variation is very small, so we choose supplier 3. Okay, so this is how we run the capability analysis. Definitely we can use the assistant. Okay, assistant capability analysis. Then we can use the assistant. Okay. Now I move to the second examples. Okay, second example, I cover capability analysis with no normal data. So let's say the data not follow the normal distribution, then how we continue. So we move to the example. We suppose we work for a company that produce the floor tiles, and they are concerned about the rubbing in the tiles and to ensure the production quality. Then we measure the rubbing in the 10 tiles each day for the 10 days. So the subgroup size go to 10. And the data do not follow the normal distribution, so we decide to analyze our data using the capability analysis suspect non-normal with the variable probability models. first I open the new worksheet. Okay, in this case I have stored the data here. In suppose I go to 10. So we go to capability analysis, expect. And because this is my first time run the analysis, I'm not sure that I can fulfill the normality assumption or not. So I use the normal first and fill in the dialog box. In this one, the upper spec is 8. Okay. Okay, so we look at the result. First, we check the stability. Okay, stable. Next, we check the normality. So we can see this portion does not fit the red line. Okay. And the p-value 0.01 is less than the alpha 0.05. So means the data not follow the normal distribution. Okay, so in this case, we look at this graph. This is skewed to the positive side. Okay, the data are skewed to positive side. So if I use the normal distributions to do the calculation, okay, can see this portion and this portion. So I will overestimate and underestimate the result. Okay, I might make the wrong decisions. Okay, because this portion they're not included in the calculation. Okay, and this also not included. Okay, so in this case, I want to. There are few ways to do it. First, we can use other distribution. So how to identify the right distribution? We can use this function. This function is under step quality tools, individual distribution identification. Okay. In send, fill in the dialog box. Okay. Suppose I go to 10. And in this case, I test all the distribution and transformation. Okay. I redo. So it's under step quality tools. Then show the individual distribution identification. Then complete the dialog box. Okay. So after I hit OK, it will come out the 4 layouts and total 16 graphs. So how to choose the right distribution? The first we look at the p-values. First we look at the p-value. Measure the p-value more than alpha 0.05. Okay. So in this case, this p-value we cannot get, so we get star. And this one box cost can fit the distribution. Then check the second graph. Variable. 3 parameter variable. Okay, then we check one by one. After we compare the p-value, next we can use the AD values. We prefer get the lower AD values. The lower is the best. And sometimes some company they fix the rules. Let's say the data not follow the normal distribution, direct use the variable distribution, or direct use the other distributions. So this one is depend the user. Okay. So let's say you use the statistical way, we can compare with the p-value first. Measure the p-value more than alpha 0.05. After this, we compare with the AD value, or we prefer get the lower AD values. Okay. So in this case, I use the variable. So I go back to the capabilities expect, and I use the no normal, and complete the dialog box. So in this case, we can choose the distribution from here. Click the drop-down menus, then we choose the raw book. And the lower spec I don't have, so leave it. Upper spec I fill in 8. Then we press OK. Okay, so we look at this graph, it fit very well. Okay, so Sam reject the first assumption. All the points within the control limit, so means the mean stable over the time. And next, we check the distributions, variable probability distribution. It fit very well, and p-value more than alpha 0.05. Okay, then look at this graph. Yes, it fit very well. Then we look at the PPK. So once we use the other distribution, we will lose the CPK values. So we get PPK values only. So my PPK value 0.77. Not so good, or still less than 1.22. Okay, so this portion is more than the upper spec limit. So we want to study on how to improve it. Okay, so this one is the first way. Let's say the data not follow the normal distributions, then we can use the other distribution. Okay, besides this method, we can transform the data. This is under under control chart post-cost transformation. And this is the first method. Or we can go to the step quality tools or Johnson transformations. Okay. So today I show is the box cost. And this method is very simple. They just put the power lambda on the original values. Put the power lambda on the original values. Then we transform the data to normal. Okay. So if you don't want to transform the data from here, we also can directly go to the capability and 6-pack normal. Then click transform. Then here also provide the function to transform the data. Okay, so let me redo. And there are a few ways. First, we can transform the data yourself. This is under step control chart, post-cost transformation, or under quality tools, Johnson transformation. Another way, we can directly go to the capability suspect normal, then go to transformations. Then we can set the lambda values. Most of the time, I use the optimal lambda. I let the Minitab to decide the lambda values. Let's say you want to do for comparison, for example, before and after. Then you can set your own lambda values here. Okay. If the post-cost this function is not work, then you can try the Johnson transformation. But Johnson transformation, it will use a very complex formulas. So it's a bit difficult to explain to the other user. Then I'll hit OK. Okay, so this one I transform the data use the box cost. Then same check the stability, normal, stable. Then we look at here. After you transform the data, then it will become a normal. Okay, p-value more than alpha 0.05. And the benefit of use this method is we still can keep the CPK values. Okay. But the weakness of this method is you need to explain why you want to transform the data to be normal. Okay. So today I show a few examples how to run the capability analysis. And now I open the Q&A sessions. If there are any questions, please let me know.
The conference has been unmuted.
Hello, good morning. Do you have any question about the web demo today?
Hello, Lydia.
Hi, yes, morning.
Hi, Kitty from AEM. Just one question. I think for the transformation, because when you transform, I think your last part is actually answering my question. Because last time I keep wondering, when you transform the data, you ever need to transform the upper spec and lower spec as well. So your last question, you do within the 6 spec, and then we do the normal, and then when you do the transformation from that, so the upper spec will get transformed as well. So you will get rid of yourself of one step of calculation, isn't it? Yeah.
So your question is this.
So the question is, the upper spec, when you do this way, it will be transformed as well, because from 8 it will be transformed to So this should be because if you use other method, you need to do the calculation yourself, right?
Yes. If you use the other methods, you need to find your upper spec and lower spec yourself. But
which is very difficult, because depend on the transformation. Some of them, the
I understand.
Yeah.
But
Okay.
But the benefit of use this method, use the postcode transformation is you can storage your original data, before and after transform. So let's say your customer want to view your transform data, then you can use this method to get it. But if you use the quality tools, direct use the capability set spec or analysis, this will direct get the final answer.
Okay, understand. Yeah.
Okay. Thank you for your questions. I received one question. Let me check. Show it. Okay, the question is, you can see the few points out of this red line, right? Okay. In this case, we still refer to the p-values. Okay. Use the p-value to make the decisions. Okay. Make sure the p-value more than alpha 0.05. That means they are normal. Okay. Because this p-value is, normally we use this as a reference. Okay. In some users refer to this diagram, they use the big pen rules. Okay, big pen rules. But I think use the p-value is more accurate. Yeah. I hope I answer your questions. If no more questions, then I stop here. And if you have any question in the future, welcome visit our website www.minitab.com or www.business.com or email us. So thanks for your attention and hope my presentation. Yes.
Lily, is it possible for you to send us your PowerPoint slides?
Sure, you can drop us the email here. Sorry, here they have a few group of people. I don't know you come from which company. Okay, you direct drop us the email, then I can send the email or PPT to you. Okay, if no more question, then I stop here. So thanks for your attention. We should have a nice day.